In this video, we're going to talk about some different sampling techniques. So these are some techniques that you can use to draw out a sample. They're all going to pretty much give you a random sample, but each one's a little bit different depending upon the situation and what kind of sample you need. So we're going to talk about 4 sampling techniques. So the first one is a random sample. Sometimes it's called a simple random sample, because in a sense all of these are random. And you can think of these as something like names in a hat. Okay, so this is kind of like when you put all the names in a hat and you just randomly draw out, 5 names, and then you got your sample of 5 observations. Now, it doesn't always have to be names in a hat. You might use a computer database, and a computer database can randomly sample observations out of the database. But the idea is they're just kind of all there together, and each one of those has the same chance of being selected as each other one. Okay? So the second one here is called a systematic sample. So for a systematic sample, this is like every, I'll say, kth item. So this is kind of like maybe you're testing parts as they come off an assembly line, and you're going to take every 10th part and test it. The reason this is random is that a lot of times K, every kth item, you randomly select that number, so you have the numbers from 1 to 20 in a hat or whatever, and you randomly draw out one of those, and then it'd be like whatever number. Let's say you drew out 13, then it would be every 13th item, and then you also randomly select the first item that comes off of the assembly line, and then you take the 13th, every 13th after that. So once K and the first item are selected, then every observation in that data set does not have the same chance of being in the sample, only every kth item. But since you're randomly selecting K in the first observation, they would take that as a random sample. And the reason for this is you want to get kind of an even observation as it comes off the line, at regular intervals. Okay. Then you have a stratified sample, and so this is when you take the population and you split it up into strata, and you randomly select observations from each strata. So let me just say randomly select observations from each, and then I'll put in quotes, strata in the population. So let me give you an example to show you what I mean. Suppose a researcher is studying self-esteem in high school populations. Okay, well, let's say this is the population of all high school students. Well, there's strata here, because let's say they want to study their self-esteem as they progress through high school. So this could be all the freshmen, this would be all the sophomores, this would be all the juniors, and this would be all the seniors. I think there's only one R there. So they're dividing their strata, or their population, into these 4 strata: freshman, sophomore, junior, senior, and then they're just randomly selecting, let's say, 50 students from each strata, and that forms their sample that they're going to use in their study. And the reason here for this method is that they want to get the kind of an even number of students from each of these categories, each of these quote-unquote strata. Okay? And then the final one is cluster sampling. And I'm just going to say here, randomly select clusters. So, and I'll put clusters in quotes. So the idea here is your sample or your population. Let's say this is the population, and it could have some clusters here, some naturally occurring clusters. And so let's just say they're wanting to test a new vaccine, let's say. And so what they might do, so let's say these are all different hospitals around maybe in the country, in the United States or something. So each hospital is considered a cluster because you have, a cluster of patients, of doctors and patients in each hospital. So these are like these naturally occurring clusters. And then what they're going to do is maybe randomly select some of these clusters. Maybe they'll pick this one, maybe this one, and that one. And the sample here are the doctors and patients in these randomly selected clusters. Okay, so the difference here is for this one, you're for your sample, you're randomly selecting from each strata, right? So many from each strata. But here you're actually randomly selecting the clusters, okay, for your sample. So that's the difference between those two. So, okay, so those are the four, and then what you got to do is determine which of the sampling techniques are being used in each case. So here's some examples for you to give a try, and what I'll have you do is go ahead, pause the video, see if you can determine which of the four sampling techniques are being used. Then you can start up the video again and see how you do. Okay, so let's see how you did here. So in a large school district, all teachers from 5 randomly selected schools are used in the sample. Okay, so that's cluster sampling. So every 7th customer entering a shopping mall is selected to be in the sample. So that's systematic, every 7th customer. Okay. By the way, number one, the reason that's cluster are you're randomly selecting schools, and the schools are kind of like the hospitals. The schools are clusters. Okay. So the first one's cluster, then systematic. The nurses in a large hospital are randomly selected for a study by using a computer database. So that's a random sample. Usually when a database picks out observations from its data, it uses a technique that's like pulling names out of a hat. It's pulling names off of the hat is the database. So number 4, customers of Northwest Airlines are divided into several different groups based on the number of times they've flown with Northwest. 50 customers are then selected from each group to take part in a study. That's stratified, so that you're taking the population, and the different strata are how many times they've flown, like maybe 1 time, 10 times, 100 times, whatever. And then they're randomly selecting from each of those strata because they're wanting to get people from each of these groups to see how, they're, to see what they think of Northwest, or whatever the study is. So 10 boxes of screws are randomly selected off the production line, and all of the screws in each box are tested to see if they meet specifications. That's another cluster sampling. So in this case, the clusters are not hospitals or schools, but they're boxes of screws. Each box is a cluster of screws, and you're randomly selecting clusters and then using the observations in those clusters in your sample. And so a sample of Hawkeye professors are chosen to sit on a committee by placing their names in a box and randomly selecting the 10 names. That is the random sample. Okay, again, it's like the names out of a hat. So that's a random sample. So those are the sampling techniques. Now there's probably a lot more, but these are the 4 that your book talks about. And these are the ones that you'll see on the homework.